we discussed about phase diagram for lead and silver system. The two component system, lead and silver system. In today's class, I am going to discuss about the congruent melting point, which is phase equilibrium. Congruent melting point. Okay, what is meant by congruent melting points? Here it is the congruent melting point, a compound which melts sharply. A compound which melts sharply at a constant temperature into a liquid of the same composition as the solid is said to be possesses a congruent melting point. First of all, we understood this congruent melting point. The what is the concept of congruent melting point? Then first I taken the two components. A is a one component and another B is another component. Okay, I mix these two components and the formation is AB component. This AB solution. I mix this component and the formation is the AB component solution. Here I take one container. Here I add first component A and B component. A component and B component. I take here this is the 80% of this and this is 20% of this. In composition, R percentage I taken here. A is a 80%. A component I taken 80% and B taken 20% and I mixed these two here A plus B and I mixed these two components in ratio here 80% and 20% composition. Then I heated this container. This container I heated I went to this is the system. First of all, when it is heated at a particular point, here the two concepts are there. I take one is the A component and another is the B component, and I cannot be reacted here. This A is A and B is B. They not combine here. These two are not combined, and here it does not lose its identity. The component A and component B does not lose its identity. And another here I take 80%. This is a container. I take here 80% of A and B is a 20%. Take any of these 70% or 30%. In composition or 80% is then I heated this. This is one number, this is one case. This is not combined and it do not react. It is only physically present in this system. Okay, only physically present in this system. And here it is chemical, it does not react one another. A component type, B component, it does not lose its identity here. And here I taken a is one component and B is another component. Same here, one A component, one B component, and here I need this container and I need this container. And I container react to form A plus liquid. Here these two are it at a one particular temperature. At in a particular point it loses its identity. Here these two are miscible. Here these two are mixed. One is A component, another is a B component. These two are mixed and this loses. You cannot find here this is A and this is B because of here these two are miscibly miscible because of one reacts but another reacts another to form another phase. Find another phase. It loses its identity. If here does not lose its identity, here it loses its identity. Here it does not react one another. Here reacts one another to form a new compound here. Okay, these are the two concepts here. Here two cases. One is react, another is does not react. I taken these two compounds. Whole. Okay, when a composition here first I already told in lead silver system. In this, you remember when you taken this 80% and this is the component B is a 20%. When you heated and cooling takes place, this is a point and here this is a point. Okay. This is one is a triple point. Just assume that here this is A point and B point. Here this is A component and this is a B component and this is a triple point here. This triple point and you here you heated the components A and B and this melts or liquid phase. This is a melt. Here this melt is you are cooling. This is cooling. Next it is separating phase. Here starts this A is starts separate. A starts separating a solid form. Here that is a solidification. When first it is start A or B. This is a liquid. You are mixed A plus B. Okay, A plus B and you are keeping high temperature and these two are in state. These two are in liquid state. In this, these two are in liquid state. And this liquid or this melt is you are cooling here the cryoscopic method. Here the cryoscopic it is cooling that is the first start the solid A. Here because of why it is start solid, you take on concentration is when it is taken composition, this A composition is high, it start first A. Or you take this is 80% and this is a 20%. Here you take an 80%, this is a 20%. First separates B component. Only the composition is high, first separates B. When those component, the composition is high, we start the separating first. The lower composition or less composition, it starts next. The solidification. Next start the converting liquid to solid. Just understood which is concentration is high or composition is high. We first start the solidification takes place here. Just I am telling about in generally here. This is important for in two component system. taken here container. This is a container. Here I taken one is a and another is a B component. Here A plus B liquid. Okay, I taken A component. This is a one container. In this container, I taken A plus B component, A component, B component, and I given high temperature, and it totally these two components converts in the liquid phase or liquid state. The phase is liquid or melt. I draw it out here. The phase diagram, the two component system. Just to understand this, what is component melting point. Okay, I taken here. This is a point here. This is a component, and another here, another this is point. Okay, next here. I take here, this is a B point. This is a A point and B point. And first to take that is I take here first 90% A and 10%. I take a container. I take here 90% A and 10% here. First, this is a freezing point of this A curve. This curve is a freezing point curve. Here temperature and here that is composition, and here this is a 100% A. Okay. I taken here, the point is here 90% A, and here this is not a particular scale, I am taking in general way. Here this is a 10% B. Okay, this here 100% B. Okay, here I get 90%. So here I write 10% A and 90% B. Okay, this percentage I taken here. First, you assume that the point is here when this is a melt or liquid. Here we have A plus B. Here one is A component, another is a B component. I given a high temperature. These A and B are in a liquid state. This liquid state I taken here. The point here 90%, 10% B. Okay, this is the point. I consider this is a point, and I am decreasing, and temperature is decreasing from here. The temperature is decreasing. We attain this freezing curve, and then this attain a freezing curve. Here this separates out. A is a solid. Okay, here this separates out. A is a solid, and here A is solid. Here the presence of A plus B liquid. A plus B liquid, and here this is the 90% A and 10% B. Okay, I already told here the presence of the concentration is high. That is first separate out A. The solidification here for A is separate out, and then it is changes the composition here. The composition is changing. This percentage is decreases. Here the B is increases. Here composition is changes. Next, this is second, and next is I decrease, decrease. I decrease here. This is here also separating A is a solid. And next type is sorry. The curve is here, the point is presented here, the formation is here, and then this here A is separate out and here A separate out and A is separate out and I am decreasing the temperature and composition is increases here, decreasing temperature composition increases and here this is a particular point, here in this particular point when in two component system here A is separate in equilibrium condition with equilibrium A is separated solid and if at equilibrium state these also start separating in two in silver and lead. I mean one component system also here is starting here the B is solid here this is not possible here another new compound is formed in this point here. Another new compound is formed. Here AB formed. Here AB solid is formed. This is the difference. Here this is also triple point. You apply the radical table in this. What is equal to 3 minus 3 1. This is like that radical table. 3 is a two component system. The phases are 3 here. One is a A solid and another is here present here also A plus B liquid and another is AB solid. This compound is formed here. This is a different. In another in last class AB is here A is solid formation at equilibrium state it attains this formation here. This is the worker and this is the two component system and here A is separating here here A is separating and attain this point and attain this point this is the rotating point. Okay, you know this is a rotating point. This A is solid is separates out and when attaining A plus B is a liquid state. A plus B is liquid state and this is cooling takes place here and cooling takes place the when it attains this point is freezing and it is next it is next cooling, gradually cooling takes place here. The finally the point attains the curve and here we reach to this point. You given in this is O and here this A is solid takes place and another when equilibrium attained the B is also separating or the B is also starting separating. B is solid and another is A plus B is a liquid. This is a two component system. If that is the system here, if this is also here, C minus B plus 1 F dash is equals to according to this stated point. This is also non-variant in nature. Here phases components are two and phases is three. One is a solid and another is a B solid and another is a plus B liquid. The phases are three here plus 1 is equals to 2 plus 1 3 minus 3 plus 3 minus 3 is 0. This is the non-variant in nature in elliptic point two component system that is a lead silver system. Okay, this is clear. But here the formation is AB solid is formation here. This is also this is triple point. It is rotating point. The rotating point not. This is a triple point here. One is A is a solid. Two different solids. One is A is solid is formation and AB solid is formation in this here. And another is A plus B liquid is formed. Three phases are present. Two solids, one is a liquid, phases are 3 and plus 1. Here is equals to 2 plus 1, 3 minus 3 is equals to 0. This is also non-variant in nature or 0 variant in nature. Okay, I taken here 100% here and 0% B. Okay, and here this point 100% B and 0% A. And I take for consideration for this point 90% A and 10% B. And I taken here the 10% A and 90% 10% A and 90% B, and I consider this the point is A. The point is A. And I this point and this liquid is already in liquid state. So this A plus B components I needed already. This is a liquid in state. And this point I am cooling here. As you are cooling the price book, I do here the price book. The point is attends here. Here the point is at this. Here the only two phases are present. This curve is two phases. One is a liquid and here formation is B is a solid. First B it is start separating solid is B. When this point is attends here, here I taken this 10% and 90% B. Okay, 90% B and this attends they start this solid separating here A is a solidification and you write here also the first A is taken here this is a and second is a solidification takes place and here there is a solidification takes place and the also here the A plus the first solid here this one and second solid is also formation this one and third also A is separating out here from here A is separating out and finally get another here this B is not formed here this B solid is not formed otherwise its formation is AB solid. AB solid compound is formed here. Okay, here the B is solid form and next the composition changes and next continuous and cooling. Here the temperature is decreases and this point the B is solid and next and here the composition changes and next cooling takes place. Here the B solid is separated, that is solidification takes place and next and cooling and changes the composition and next time cooling takes place. Here they attain this temperature. Here this is a triple point, this O point, this attains a triple point. Here there are three phases. One is a B solid and another is a AB solid and another is a AB liquid. These three phases are present here. You have understood here. This is a container and here the presence of A is a B is a solid and another this is AB is a solid and another this A plus B is a liquid. These two and here the same. This is also triple point. Here 3 minus 3 it is a non-variant or invariant in nature. Okay, up to here you have to clear this points up to here. This is a easy way. Next it comes a congruent melting point. Here I take here it is a 760 foot. 60% A, 40% B. Okay, this is not particular scale or I take a 70%. Yes, 70% A and 30%. Take any composition here. This is the in this particular composition. This particular composition here the curve is this continuation curve is formed here. This type of graph is formed. This type of phase diagram is formed here. Here, the presence of, or this we can consider that is this is a 70% A and 30%. Here, this is, we have to consider 30% A, 70% B. I am considering this point. This is not a particular scale, only I am taking the general. Here I consider 60% A or 40%. Okay, I taken 30, 60, 40%. Here, the formation of, in the presence of this melt liquid, I have a plus B A component and B component. This particular temperature and this particular composition here in a temperature you are decreasing, you are varying the temperature here. Here the varying temperature, here you are here the A plus B is in a liquid state. This A plus B is liquid state. This temperature, I cool this temperature, the whole this liquid is converts, it is on this spot, that is solidification. That is a solid. Here this whole this solution is, when this point comes to here, the whole solution is converts in a solid. This is known as a congruent melting point. I hope you understood these things. Here, this is a particular composition. Here, I am decreasing temperature. Here, freezing this liquid solution, this melted solution. I am freezing. I am going to freeze gradually here, that is, yes, suddenly converts in a solid state. Or here, this is a, I am increasing temperature, whole solid converts on the spot in a liquid state. This is known as, in same composition is same. Here composition is same, just where I am just decreasing, increasing temperature. Only I am decreases 1 degree Celsius, all liquid converts in a solid. Only I vary only 1 degree Celsius. All liquid changes in solid, all solid changes in liquid in the same composition, that is known as a congruent melting points. Here AB is a liquid state. When it comes in this state, here in this area, that is AB is a all solid in state. That is same composition. Composition is same, but the changing, the phases are changes, solid, liquid. On the spot, the whole solution is converts in a solidification, and whole solid converts in a liquid state. This is known as a congruent melting point. So this is the concept of congruent melting point. I write this diagram once again. These things all the sorry understood. The congruent melting points and incongruent melting points, only one small difference, congruent and incongruent melting point. a graph or it's a diagram or a congruent melting points. This is very important for a ferric chloride water system. This is a and this is B and here this is separate out. A is a solid and next composition changes. Here A is solid and next it changes the composition and here also A is solid and next the composition is changes, it gets a triple point. Here A is a solid and AB is a solid and another this is a triple point. This is compound formation here. Compound formation. This is known as a triple point. This AP formation. In this point AP formation takes place and up to here this is the A percentage and this is the B percentage. Up to here this is a is solid. This is here AB is formation. Up to here B is solid. And this point is 90% A, 10% A plus. This is equaling step. Okay, here. Next changes the composition, next changes the composition, next changes the composition, and finally get this point. Here separating AB solid, AB solid, here also AB solid. And this particular point here A plus B is a liquid and here AB is a solid. And here I consider here this is a point and putting here this is A plus B. Here A is a 10% and B is a 90% and here it change composition and here and formation is here. Here also B is solid. Here this is B is a solid. And here also B is solid. Here also B is a solid. Here this is AB solid and A plus B liquid. This is a triple point. Here also increasing here and formation is AB solid and changing concentration and composition and here formation AB solid. Finally get this AB solid is formed. This is a phase diagram. Here present three phases and here also present three phases. One is A plus B liquid and AB solid and B is a solid. And here A solid, AB solid and another AB liquid. And here the First, in a particular in a composition, this is in particular composition. Here, A plus B is a liquid in state and E. Only here, the presence of only AB is a solid and AB is a liquid in state. The sudden on the spot, the here the presence you see here is a here the liquid presence in a higher the liquid I heated higher temperature is going to here this point here this point is a higher in liquid and I am cooling just very just it is very 1 degree that is my 1 degree Celsius. This 1 degree Celsius it decreases here on the spot. The whole solution is converts in a liquid state that is called as a congruent melting point. And here the increased temperature, the whole solution converts in a liquid state that is known as this is also known as a congruent melting point. In same composition, changing the phases. The same composition, you change the solid to liquids. This is known as a congruent melting point. For example, here in your syllabus on this congruent melting point, the ferric chloride divided the ferric chloride and water system is there in your syllabus and another you take an example that is the zinc and magnesium and aluminum and magnesium. Take many examples for here aluminum magnesium and mercury and thallium and another is gold tin and another example phenolaniline and amongst here salt hydrates that is a ferric chloride water system. This is a congruent melting point. Right? Definition of congruent melting point. I already told in starting here what is meant by congruent melting point. Only in the congruent melting point this differences takes place only. Here this curve changes only this differences form here. Only this changes this type of this. This is the incongruent melting point. This is the one special condition in incongruent melting point. Definition of congruent melting point. A compound which melts shortly compound which melts sharply which melts sharply at a constant temperature at a constant temperature at a constant temperature into a liquid of the same composition of the same composition the same composition as the solid as the solid is said to possesses is is said to possesses a congruent melting point. Congruent melting point. This is a congruent melting point definition. In an examination one and 1 marks is asked this question: congruent melting point, a compound which melts shortly at a constant temperature into a liquid of the same composition as the constant temperature at is a very temperature into a liquid of the same composition. The presence of same composition as the solid is said to possess a congruent melting point. Okay, second one, incongruent melting point. Here, incongruent melting point, only the difference is here. I take this is a graph phase diagram. This is point A, and this comes here, and here this comes here, and this comes here. In congruent melting point, here this is A, and this formation is this type. Okay, the formation is here. This type is a congruent. Incongruent means this is a phase diagram. Okay, here the formation up to here, this is and this is special condition for here. That is this point here, the presence of liquid, here, the presence of liquid, and here the one other point, triple point here, the formation is triple point. The I taken A plus B is a component, and this is a liquid state. I already treated this, and here the formation here A is sorry, B is separated out, and here B is separated, and this point I am cooling here, this point you go on here, the cooling takes place here, and the formation, this is a continuation point here, this continuation point here, the separation takes place here, AB, and also B is formation here, AB solid is formed, and another B is solid is formed, this continuation line here, this is known as a here the point is present here also solid B plus liquid and solid AB. Here I write also this equation is converting to original solid to new solid and solution, that is when this equation is S1, this is the original solid, and converting new solid S2, this is a new solid and plus solution. This not equilibrium here, these two are equilibrium not here, one another in equilibrium. Here S1 is equilibrium, this solution, S2 is equilibrium, this solution. Here original solution, original solid is formation is new solid in this here, AB is a new solid and the solid solution. This point is a very important at this, and this reaction here decomposes here, the decomposition reaction takes place here, the formation is a new solid AB solid here, or it is sorry I taken here S1 and S2, here S1 is a and S2 is a formation AB plus solution. and this point is known as, this is a triple point, and this point, this continuation point, this point is known as a peritectic point. This point is known as peritectic point, or it is also known as a peritectic point. Peritectic point. These are the, or it is also known as a peritectic reaction or peritectic reaction, also known as a peritectic temperature or peritectic temperature. This is a incongruent melting. Here the incongruent melting points. Here the liquid state, liquid and another formation. These are not equivalent here. The only it is a one. It is equilibrium in one another here. And this particular point is known as a peritectic point or a peritectic temperature. And here you can take this incongruent melting point example in your syllabus, sodium and potassium system. Here and another example, picric acid, benzene as an example. Another example, gold and antimony is example. Sodium, potassium example. Amongst the salt hydrates and the sodium sulfate and water system. These are the example for this incongruent melting points. And here incongruent melting point means I write. I did it here only. Incongruent melting point, in many systems are with this incongruent, we one another combination of compounds to form reagents or to form two components to form a many systems form a compounds in a new formation of compounds, and instead of this melting congruently, decomposition and heated giving a new solid here. The incongruent means the decomposition when heated giving a new solid phase and a solution with composition different from that of the solid phase. Such a compound is solid to have an incongruent melting point here. This is the solid is present, a different solid is formation, the form that is a compound is solid, that solid compound is known as a incongruent melting point. And as I told examples, citric acid and benzene. And in your syllabus, potassium, sodium and potassium system. This is the concept of congruent and incongruent melting point. I stop here only. Continue next.